Alright, it's your boy, the Knologist. Yes, team, this is the question that everyone has been waiting for. And I'm going to be honest, I have no fucking idea how to solve it. This is inverting a binary tree. That dude on Algo Expert, one of those platforms, he does this in one of his coding interviews, and this is like one of the most famous questions I've come across. People get stuck on it all the time. I'm going to give it an attempt right now. Invert binary tree. Given the root of a binary tree, invert the tree and then return its root. Okay. This is supposed to be an easy question. I have no idea. Okay. All right. Okay. How would I do this simply? Okay, so let's take a look here. This is my node. This is the root. Okay. And I'm like intimidated by just the sheer, all the rumors about this question about how tough it is. Okay, so this is the node and it points down. This is a node and it's pointer, so it's got its left subtree. So let's say at the very L R. Okay. So what I want to do is I want to take whatever's on the left and swap it with whatever's on the right. So let's take that. So basically, if I was to look at this, I would look at the left, I'd look at the right, and then swap them. Swap them based on this root node. So let's say if it had another 2 and another 2, I would look at this node and then swap this with this, and then swap this with this, and then swap this with this. So this is kind of telling me that we use recursion, because if as long as we keep going and making more of these, we just keep following the pattern. We keep following that pattern, right, of swapping this and this and swapping this and this, and then swapping until you go up till the top. All right, so let's see if I can do it for a simple, just a 2 node thing, and then let's see if we can abstract it up until a different level. Okay, so I'm given this 2, 1, 3. So I think first I want a helper function. I want a helper function. So I'm gonna say def helper, and it takes in a node. So this is gonna be the target node. And then what does it do? What does it do? So this node is supposed to look at everything on the left, everything on the right, and then swap. Okay. So the case here, in this case here, these are leaf nodes, because there's no children after these nodes. So if we look at this, boom, boom, there's no children here. So this is how we know these are leaf nodes. So this is the most simple way to swap. So this is what this is telling me is, if we get to a leaf node, this is when we know when to swap nodes. Okay. So if I'm given this node, and I get to a leaf node. So if node dot left and node dot right is none, and node dot right is none, we've reached a leaf node. And at this point when we reach that leaf node, okay, the other thing is I want to know that it's always balanced. Number of the nodes in the tree. Okay, so if it's 0, if nodes of the tree is 0, return none. So let's do that. So def, so I mean, if root equals none, return none, because there's nothing to do this flip on. Okay. If the root let's do other thing. All it does is flip, because it can be from 0 to 100. If it's 1, return the root. So if it's got no children nodes, if the root is on its own, so if this is thing, so I solved this test case. Now I want to solve this test case. This is the most important one. So if I reach a leaf node, this is the point at which I need to swap something. So if I reach the leaf node I want to return, I have to really conceptualize this. How do I swap? That's the thing. How do I get from here to here? I want to take whatever's on the left, put it on the right. This is how I know when to stop, so I could keep looking at whatever's on the left. What do we got? Val, left, right. The actual value doesn't matter. All we care about is left and right. How do I take left and put it on the right recursively? I'm thinking of maybe storing it. I don't know. Within its subarray, you got to do it. So all you need is that node up here. All you need is this root node. Oh, if node.left equals none, or node.right equals none, node.left swap node.right, or node.left So what do I want to do? I want to call helper on node. Helper node.left, because I want to go to the left. How much time do I have? 10 minutes. Okay. Helper node.left. Yeah, it's gonna keep going left, left, left until I hit here. Then I want to swap. Oh. Do you know what? I could put the if condition here. So this is my base case. Then I want to say if node dot left. Actually, I don't even want this to be my base case. It's not the leaf node that I care about. I'll make this my new base case. If node dot left equals none, because then we know this is a leaf node. Node dot left equals none because I passed through the 2. Or node dot right equals none. Don't hate on me, guys. I'm trying my best. If this is the case, if it's one of these situations, then node dot left temp equals node dot left. Node dot left equals node dot right. Node dot right equals node dot left. Oh no, not node dot left, because that's going to be node dot right. So that's going to be temp. Return. And then I just go node dot left and keep going left, and it's going to keep doing this check, and then helper, because we have to traverse the binary tree to figure out where to swap node dot right. Oh no, we only have to do it for one side because we have to swap. Oh my gosh. Oh my gosh. Because we only have to do it for one side because we got to swap with the other side. Because if we swap with the other side, then we just swap it back. It makes no sense. I don't know, this is my assumption, right? Because all I want to know is that there's nothing on this left side for me to switch it for this base case. So then why not do the same thing? I just want to check what's on the left and flip it over. Just want to check what's on the left here, flip it over, right? So I'm just going to check what's on the left, flip it over, and keep checking the left until I hit this base case where I return. And then I'm going to come back to this root, right? And then I'm going to return the node. Okay. And then I'm going to go return helper root. this is my attempt. I'm gonna try. I don't know if this is the correctest way to do it or if there's a better way or something, but I am going to try. All right, I gave it my fucking best. All right, guys, don't shit on me. Come on. One of the cases. Okay. Okay, I butchered that completely. Okay, so expected 29631. I got 427. Okay, I fucking butchered this completely. What if I do if node.left equals none or node.right? What if I do that? What if I do it with both? So let's go left. I just want to see what's going on first. Can I do this? Can I even do this? Is this closer or is this further? Okay, so this isn't doing anything. So node.left.left. So I'm going to keep traversing until I hit node.left or node.right equals none. Let's try this as the base case. If any of them is a thing. Okay, 4271369. Okay, why doesn't that work? Okay, input 427. Oh no, fuck! I got my hopes up for no reason. 4271369, 4271369. Output. My output's the exact same as the input. Okay, so what if I do both sides? Node dot right equals. I'm just curious. Does that change the way this output is? Okay, so that doesn't change the way this is. Okay, so what if I go back to my original way with the right side? I go node.left.left. 4273169. So 3169 and then 3196. Okay, so this, you see here, 427, so something is not right here, but it's not the same. So 427 is normal. The 31 is flipped. 4279361 and then 4271369. This tells me that something isn't flipping correctly. So node.left.left equals none or node.right equals none. So I could flip on that side and that might give me these two flips. So you see, this is exactly the pairing, but they're not flipped enough. So let's try this. Come on. Why? Okay, so this doesn't affect it. This is what it's telling me. This doesn't affect it. So it's got to be something else. So this is correct, right? This flipping of the nodes is correct because look at this. 1-3 becomes 3-1, right? And we want 3-1. We just want to shift it to the right. So what if I just do this? What if I invert it? So I go node.left.left. Then I go helper. I cut this out. So I'm just using the clues to figure out how to do this. I'm using clues from my outputs. Let's try that. That should fix it. Why? Oh, I think I figured it out. This doesn't affect it, but I think I know what to do now. 10 equals node.right. Node.right equals node.left. because I'm checking for the left, so I want to swap with the right. Then node dot left equals temp. Return. No? 319672 2772 31. See, like, these two trees have to be flipped. I just have to figure out how to swap the two trees. Oh, okay. Wait. So I'm getting the correct flips here. Right? So then all I have to do is go back to my answer, which is the return node. I just have to go back to my answer and flip those roots, and that should work. So final equals helper roots. Then I have to go temp here. Temp equals so temp equals final dot left equals final dot right, right? And then final dot right equals temp. Then I return final. This should flip my trees on the output side. This should flip. Why? Fucking. Why? What is wrong with what I've done? (4713, 4271, 42769). Why? What am I doing that's wrong? Why can't I do it? Root dot right, root dot left. I just have to flip whatever's here. So final temp. Final dot left. So if it's none, okay, so final dot left equals final dot right. So temp is final. I save it in this. Why don't I just do this? Okay, so I put save final in temp, right? I'll make a copy of this, and then final dot left is temp dot right because it's final. And the final dot right is temp dot left. Return final. That should solve it. Come on. What the fuck? Why? Why doesn't it work? It literally fucking. Do I have to solve it within this? Okay, so final. So look, if I go here, helper root, right? It returns the output, but it's got the trees flipped. So I need to somehow flip these trees. What if I do this? If no dot left is none. Does this give me the same output? This is all I care about. Does this give me the same output? 1369, 1369, 6931, 1369. See, this is wrong. You see that? This is wrong because this is flipped, right? So dot left. So now I have the right order. I just have to make the trees switch over. Okay, temp equals node. Temp dot right. Return node. Let's try that. I just want to see where the issue is. Where is it? Where's the issue? Okay, 1166. Node already is temp dot left. Return node. See, this is completely wrong. Okay, so if I remove this, do we get closer or further away from the answer? I'm just trying to figure out how to flip. Okay, this is wrong. What if I just don't do this? Run. 1169. Then what if I go node dot temp equals node dot left? Node dot left, node dot right. Node dot right equals node dot left. Node dot left equals temp. Yeah, node dot right equals node dot left. Node dot left equals temp. Let's delete the right because we don't want to flip it again. Where are we getting? What are we getting? 6996. 4273169. 4273196. 4273196. Okay, what am I at? I'm struggling right now. I'm struggling. We're nearly at 30 minutes. Okay, so let's bring it back to what was just one flip away. Because if we do this, right? If we do this, it's at least one flip away from being correct. Right? All I have to do is switch these positions and switch these positions to get the final answer. So I'm returning the node with the flipped trees. That's the only thing that I don't get. Okay, so I just have to find a way to flip these trees. It's probably something super obvious. I'm just gonna put this in ChatGPT. Let's see what's going on. Let's try it. I gave you guys my logic. I gave it a good try. I gave it a good honest try. Right? My code. And then I got close, guys. I tried. Don't shit on me. Don't shit on me. Y'all know this is harder than it looks. There's a dude on LinkedIn that I think created Brew, one of the programs, and he didn't get a job because he couldn't invert the binary tree either. Right? So if that guy couldn't do it, what the fuck? Swap recursively. If root is none, return none. Okay. Oh, so they're doing a swap at every little turn. You see that? Okay, so what's happening here is, what are they doing? Okay, so root that right. Correct my code. Yeah, see, the helper function does not correctly handle the swapping of nodes for the entire tree. The base cases of regression are not well defined. Directly check a node that is incorrect as it does not account for nodes that may not exist. Okay. So it's basically going all the way till the end. So basically what it does is, this is a swap. So it's doing a swap. So it's basically saying if node equals none, return none, right? Then it says basically if, so node dot left, node dot right equals node dot right, node dot left. So it swaps, then it goes helper node dot left, helper node dot right. So it basically goes from, we usually go, and this is where my misconception was. I was thinking you have to go down to leaf node and swap from the leaf. But what this solution is doing is it's swapping from the root down. So it's swap, 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 swap till it hits the leaf, swap. And then it returns the base, it returns the node at the very end. See what I'm trying to say? Because when it returns the base case and you pass everything back up, all that's left is the top node that you originally had. So if you run this, it should work. Wow. Wow. Wow, 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 wow. See, this is the beauty of recursion. Like, you just see it unfold. It's like a fucking flower. It's like a flower of life. Beats 10.3%. So let's walk through this real quick. I just want to show you guys where the misconception was. I thought you had to go 1, 2, 3, all the way till the end, swap, 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 and then swap the big trees at the end. What they're doing is completely different. They're going and they're swapping the trees from the beginning, and then they're going boom, boom, swap, 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 swap until it hits the very end. So it basically recurses through the whole thing, but it swaps every fucking thing until the end, starting at the root. So you're going swap, swap. So this is in the next place. Then you go to the next level, swap, swap. And then you go to the right side, swap, swap. You see what I'm saying? And then until you hit the very end. So basically top down swaps. So it's like these swap, then you go to the next iteration, then it goes these swap, then you go to the next iteration, then you do the right side, these swap, you go to the next iteration, and then until you hit the very end and the root is none. That's crazy. That's actually crazy. I wouldn't have thought of that off the bat, but I understand how it works. It's just like you have to figure out how to conceptualize what you're looking at. So the way I was conceptualizing was like the way I usually do it, right? I look for a root node to be my base case. A leaf node to be my base case. In this case, they're just swapping as they go. right? Swap as you go till you hit a leaf node. So that was where I made a mistake, right? Because then it just works out perfectly. Because I was always looking at, if you look at my tree and my outputs, it was just one swap away. The reason why is because it was doing everything from the leaf node up, and then something was getting lost in translation, or it wasn't just hitting the right conditional, right? Because I was going to note that left. Maybe there might not be a left, right? As you saw when I tried returning up here, right? This way, you always know when a node is none, right? Because it's only that iteration on itself, right? There's no left. So left could be none, left is for sure none, right? So you can't know that, and you can't pass that on as a value. It's going to throw an error up here like you saw earlier. So this is a good learning experience for me and for anyone watching. Don't assume all the recursive strategies will be the same. Sometimes you might have to do it in reverse, right? Maybe you have to go from the root down instead of from the leaf up. You know what I'm saying? So if you enjoyed this video, please give it a thumbs up. Subscribe to the channel and leave your comments below. Knologist out.